perfect square that goes into this. By now, you probably know how to test perfect squares that go into it, so I'm just going to tell you right now that 4 goes into this number. So this we could split up to be square root 4 times 34, square root 34, and then simplify that. Square root of 4 is 2, square root of 34. No way to simplify it further. That is our final answer. Okay, this video is getting much longer than I would like for it to be, so we're going to speed through the rest. Cut this up into right triangles because we need to find the height of this triangle in order to find its area. Round intermediate values to the nearest tenth. So anytime you get a decimal on the calculator, round it to the nearest tenth. All right, so that right triangle that I just split it up into, the hypotenuse is 11 and the base of it is half of 19.2. which is 9.6. That means this side, hey, we can use Pythagorean Theorem to find the height. By using Pythagorean Theorem, we can find that x, which is the height of this triangle, which is the height of this triangle, is actually 5.4. And then we can plug it in to find the area of this triangle. The area is 1/2 times the base, 19.2, times the height, 5.4. Hey, guess what? 11 is not part of the area. Not helpful to us except to find the height. All right, plug this into the calculator. And we get 51.8 units squared. All right, find the missing side, round to the nearest tenth. They gave you an angle, they gave you a side. We're going to use SOHCAHTOA. Circle the angle that they gave you, not just any angle. Circle the angle they gave you because that's the one we want to focus on. All right, opposite does not touch the focus angle, hypotenuse does not touch the right angle, and the adjacent touches both. So we need to find the opposite. They gave us the hypotenuse. That would be sine. Sine of 69 is equal to the opposite side over the hypotenuse times both sides by 19. Why? Not just for the fun of it, but to get x by itself. That's the goal here. 19 sine 69. That is 17.7. Calculator does the work for you. Awesome. Find the measure of the indicated angle. They gave you two sides. You need to find the angle. Same thing. We're going to use trig again. Except for this time, we're going to call the angle theta. Label your sides. Circle the angle that they want you to find. Opposite, adjacent, hypotenuse. They gave us the opposite and the adjacent. We're going to use tangent. Tangent of theta is equal to 10 over 13. How do you undo tangent? How do you get rid of tangent? You do tan inverse of both sides. Tan inverse of tan of theta is theta. Tan inverse of 10 over 13 I thought actually maybe I should show you how to do this. So second tan of 10 over 13 is 37.6. And they said angle to the nearest degree, so 38 degrees. Moving on, special right triangles. Line up the sides that correspond with your special right triangles. For the 45, 45, 90, the hypotenuse is the x root 2. The legs are both the same x. For the 30, 60, 90, lining it up, the hypotenuse is the 2x. The short side is the x, and the other leg is the x root 3. Okay, so we're going to call this x, we're just going to call it z to make our lives a little bit easier so we don't have repeat x's. Okay, make them equal to each other so we can get x. X root 2 is equal to 8. Divide both sides by root 2 to get x by itself. X is equal to 8 over root 2. hey, guess what? Can't have a radical in the denominator. So we're going to rationalize the denominator by timesing by root 2 over root 2. And we get 8 root 2 over root 2 times root 2 is 2. Hey, we can actually reduce that. I'm running out of room over there, so I'm going to put it here. 8 over 2 is 4. 4 root 2 is the length, is x, is the short side. Hey, guess what? That's n and m. So n equals 4 root 2, m equals 4 root 2. 31. They gave us the hypotenuse, and it looks really awkward, so let's set it up. 2x is equal to 6 root 3. Divide by 2 to find x. X is equal to, hey, we can reduce that. 6 divided by 2 is 3 root 3. This is the short side, not this side. Just because it has a root 3 in it doesn't mean it automatically becomes the leg across from 60 degrees. Root 3 could be a part of any answer, okay? It's just that for this leg, if you know the short side, all you have to do is times it by root 3 to get this leg. But sometimes root 3 is there, and sometimes it's not, and sometimes it's here, okay? So don't get confused. Just because you see a root 3 does not mean it corresponds with the root 3 leg of the triangle. All right, so y, this right here is 3 root 3. All right, in order to get z, z is equal to x root 3. Hey, you know what x is. It's 3 root 3, so plug it in. 3 root 3 times root 3. Root 3 times root 3 is 3. 3 times 3 is 9. Z, or what they used to call it was x, is equal to 9. So there we have our answers.